Welcome to week 2 of COMP3311. Alright, so each week I'm going to do one of these preview videos which tells you what's happening in the following week. Alright, so in this week we've got data definition in SQL, how to map ER diagrams to SQL, and a discussion about DBMSs and how you actually manage data in them. A couple of activities for this week. The first quiz will be up. May not be up when you see this video, but will be up soon. Assignment 1 will also be available soon, probably Monday or Tuesday. And obviously it's not due till 11th of October. In Tutes this week, so Tutes start this week, online, Blackboard, Collaborate. It'd be nice if we could try and somehow set things up so that it's a little bit more like an face-to-face session. So that normally you'd be sitting in a room, there'd be tutor up the front, and there'd be a whole bunch of students sitting around the room. And you could all see each other and you could all communicate with each other. It'd be nice to try and set up something like that, inside Collaborate. I'm not sure how possible that is. If it's no good at all, we can look at using some other platform. Also, there's a new prac exercise out this week. If it's not out by the time you see this, it'll be out soon after, like Monday. And the idea here, relatively important, install a Postgres server somewhere as soon as you can. The prac exercise 02 tells you how to do it on CSE servers, how to do the installation, and it's very simple. Home installation is going to be slightly more complicated, and I can't predict what kind of operating system, what kind of hardware you've got. So your best bet is to look for install PostgreSQL on Google. Alright, I just wanted to say a couple of things about Postgres if you set it up, if you run the server at CSE, and you probably all should eventually. So one thing about Postgres, it's a little bit of a disk hog. It will chew up a couple of 100 megabytes, which may not fit under your home directory. So to handle that, there's an alternative file system called /server, lives on a server called Greek, and you can make a directory there for you to do all your database work under, and that'll give you a quota of 500 megabytes or something, which should be enough to hold a Postgres server and a large database under that server. So you'll need to log into the Greek server, SSH Greek. Once you're on Greek, then you can create this /server directory. Won't exist automatically. You have to run a command called privserver, and that will create that directory. Once you've got that directory, it's probably a good idea to cd into it just to make sure it's there. And once you're there, run the command pginit, which actually lives in the CS3311 bin. So ~CS3311/bin/pginit. And what that will do, it will set up it'll set up one directory and a whole bunch of files in that directory and some other subdirectories for your Postgres server. And that sets up the whole thing. When you want to run your server, you have to make sure that the environment is set up appropriately. And one other thing that pginit does, it copies a little script called env into your /server directory, and you need to run that each time you want to have a session with Postgres. So you'd source env to set up the environment. Then a command pg1, also in CS3311/bin, will start the server. You can also type pg start, and once you've finished using the server, pg0 or pg stop will stop the server. All of the data files live under /server your name pgsql, and you can go and have a look at that directory and see how it's structured if you want. That's on Greek, and those files will persist even when you're not using the server. So you can log into Greek, run a session with PostgreSQL, log out, come back, start the server again, and all of the databases that you're playing with will still be there. An alternative is to run the Postgres server on some other machine in CSE, and typically this means a lab machine. If you try to run it on one of the big servers like Wagner or Williams or Weil, the server will get terminated pretty quickly because they're not designed for running or for having long-running server processes. However, when you run it on a CSE lab machine, it's actually going to run under /temp, and you'll need to recreate the server infrastructure, i.e. all of the files, every time you run it, which means also that the databases that you create there aren't going to persist, which kind of a little bit defeats the purpose of having a database, but that's the price you pay for running it on one of the CSE lab machines. The advantage of doing it there is that you're not sharing the server with 200 other people, which you would be doing if you were trying to run it on Greek the night before the assignment is due. Alright, in any case, all of the details for how to do this are available in Prac 2. Alright, another famous DB nerd, and I love this slide because it's a late middle-aged guy sitting on a motorbike with a red tank. To me, that screams midlife crisis. But that's not really the point. It's who is this guy and what did he do? And I can add a bonus question, where is he currently sitting? And I'll explain all that on the next slide. So his name is Don Chamberlain. He works at the IBM Research Lab. It used to be at San Jose and now is at Almaden, in the middle of a county park, and they have mountain lions wandering through the park and past the research lab, and that's actually where he's sitting on his motorbike. Maybe he's ready to make a quick getaway if a mountain lion appears. In any case, he was a member of the team that built System R, and I've mentioned System R in the SQL intro video. System R was the original prototype relational database. So the relational model was developed by Ted Codd, and before System R, no one had actually built a system that used that model for storing and manipulating data. So the IBM people decided they wanted to see if you could build a relational database system that was actually useful. Alright, so one very important thing that Don Chamberlain did was to design SQL. He did that with another guy called Ray Boyce, who I'll talk about at some other point as a famous DB nerd. I'll probably mention quite a few of the people that were involved in System R, because that's really an important milestone in the development of relational databases. Alright, after System R, He went on to work on DB2, which was, if you like, the successor to System R, but it was IBM's, I guess, challenger to Oracle in the real world of database usage. He worked on that for a while, and then things like XML came along and people wanted to incorporate XML into databases. If you're trying to do things with XML and a database, you need quite a different query language to SQL. So he was involved in the development of query languages for SQL. He also worked on a more modern database called Couchbase. And because of this seminal work in relational databases, and in particular System R, he's been awarded an ACM Software Systems Award, which probably went to all of the other members of the System R team. But I think his contribution really is the design of the SQL language. Now, if you decide you hate SQL, you now have someone to blame. Alright, so that's it for week 2. Enjoy.